Okay, so mic check. Mic check. Seems fine. Okay, so think. Mm, 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 mm. Okay, so let me just see if my voice is fine. Okay, it seems fine. So we'll be solving one question, and then if I get any questions, I'll try to answer any question, and that's it pretty much. Settings seems to be fine. The stream health also is fine. It doesn't have any problems as such. Okay. Hopefully someday, I don't know when, but someday we'll have more than 10 viewers. In these scenarios, it becomes very difficult to get these many more than 10 viewers for channels like mine because we don't do any badmashis, as they like to call it. पढ़ाई लिखाई करने वाले बच्चे बहुत कम हो गए हैं. अभी कोई कंट्रोवर्सी करेंगे तो बहुत आ जाएंगे लोग. गुड इवनिंग रेडियन. Okay, so I think we can solve this question. Probably this is actually a very easy question. I don't know why do I even have this in my palette, but still seems like uh, the other questions are also fine. Okay, so let's do this. It says that when a number is divided by 15, the quotient is an odd number and the remainder is 1. So what can we do with this type of a question? The setup in itself is pretty evident. N divided by 15, remainder is 1. What will be the remainder when it is divided by 30? So, prediction time. We know the Euclid's division lemma, which is of course dividend is equals to divisor into quotient plus remainder. This is the first thing that you are taught when you are in, let's say, 6th standard or 5th standard. I think it's in 6th standard only. If I remember very vaguely, in my 5th standard or 6th standard, I was taught this thing. So, yeah. So, any number is basically can be written as a product of its quotient, divisor and quotient and the remainder. So this is what the division lemma is. Now, this is basically to tell you that there is some way possible for us to understand the type of the number, or let's say predict the form of the number, what type of a number it is, form of the number. So although I will not write any of these things in a copy or whatever, when I'm solving these type of questions, but it helps me immensely when I write n by 15 and remainder is 1. So I know that whatever this n is, it can be written in the form 15k plus 1. Now, other than this much information, I don't think we have anything. Just one more thing. We have the nature of the quotient also. Now this is the quotient, quotient is k, and that happens to be an odd number. So how do we represent an odd number? Representation of an odd number could be of myriad types, but the one that I am going to be picking right now is 2k plus 1. 2k plus 1 seems like the representation that can really help me with my prediction. If I substitute the value of k as 0, any whole number, it will become 1, that is an odd number. If I substitute k is equals to 1, it will be 3. The number k will be 3. Okay, or the representation of k should be of the form 2n plus. I could have used k dash also, but 2n plus 1 is fine. Okay, so so this n in its entirety can be written as 2n plus 1 time 2n plus 1 plus 1. Interesting. Now what can I do? So now all I need to do is just open the bracket or rather multiply this thing. So this is 20, sorry, I'm writing 20, 30n plus 15 plus 1. So this n can also be written as something like this. N can be written as 30n plus 16, and this is it. With this idea, I have ascertained the number n could also be written as 30n plus 16. Now, is this not similarly the form that we were using in the first part, that is dividend, divisor, quotient, remainder? So here the quotient divisor is 30, this is the quotient, this is the divisor, and of course this is the remainder. So when the number is divided by 30, we will have some quotient. Now what that quotient is, I'm not gonna get into that, not important, but effectively the remainder is going to be 16. That is an interesting thing. Remainder comes out as 16. So effectively speaking, the answer to this question would be 16. Do I need it to do all that? Maybe, maybe not, who knows. But this is something that could have been used. So I think we'll do one more question. I'm just trying to build up my, shall I say, I'm just trying to build up my patience for the live sessions. I don't know how long I'll be able to conduct these sessions. But actually the fact is that I'm quite happy because the settings are not really giving me any pain in my neck. So let's go to the next question. The next question is this one. Find the greatest number which leaves remainder 10, 8 and 6 when it divides 70, 80 and 90 respectively. So basically there is a number that divides 70. Now what does it mean? The first thing that you need to understand is that 70 by n, remainder should be 10. The other part will be 80 by n, the remainder should be 8. and 90 by n, should use the same capital letter N, remainder should be 6. So this is basically the idea that one needs to understand for this question. 71 gets divided by this number, should leave a remainder of 10 and 8 and 6. Now if anybody breaks down this idea like this, I think now it's a matter of couple of seconds to get to the answer. Because if you can see the question like this, you realize that what exactly we are doing. We are not going to be predicting the type of a question by the name greatest or least. Somebody has this problem that, the moment I see greatest, so invariably it has to be an application question from GCD, which is greatest common divisor, basically the HCF, highest common factor. But if we understand the question, this is what the question is asking us to do. There is a number, a greatest number, and we need to find that greatest number, which should leave the remainder of 10 when it gets divided, when it divides 70, okay, 8 when 80, and 6 when 90. So, I mean, too much elaboration has been given. How do we do this? How do we solve it? It is just one number, and that too we are looking for a greatest number. Obviously, that number needs to be a factor. We can make the number a factor, and if that number n, rather I should say, I should use my words properly, if that number would have been a factor, it would have been much easier for me to calculate. Right now, because different remainders are there in different cases, the number n is not a factor. That means if I just subtract 10 from the first one, I get a 60. 70 minus 10, 60. That when gets divided by n, remainder 0. Similarly, 80 minus 8 is 72 by n, and again remainder is 0. Similarly, 90 minus 6 is 84, right? 84, n, remainder 0. Now, if this is the case, all of them are getting remainder 0. That means effectively now n is a factor. N is a factor of these particular numbers, string of numbers 70, 80 and 90. So what I understand is that now if I need to find the greatest number that will leave remainder 0, 0, 0, effectively that is the greatest common factor or divisor, right? HCF. How do we calculate the HCF? There are many ways to find the HCF. Okay. One of the basic ways is to just, break it into your prime factorized form and then get the common, let's say prime basis and the lower index. Or you can also do one thing. You can just write the numbers and let's say take away a number, the greatest number from them, so that all the, let's say, multiples inside should be co-prime. Okay, so what I can see is that I can take away 12, 5s are, 6s are, and 7s are. Right, there is no commonality between these numbers 5, 6 and 7. So in fact I can say that for this particular these particular numbers n1, n2, n, or you can say n, n dash, n double dash, we can say the highest common factor is 12. This is one of the ways to calculate the HCF. Again, there could be myriad ways to calculate the HCF. I don't know, you can see that. Hopefully now you can see it. So these numbers are co-prime to each other. So there is no commonality. The only highest common factor between 60, 72 and 84 would be 12. And the answer to this question also will be 12. That will be the answer. Okay, we can check that also. Because if I divide 70 by 12, I get a 10 as remainder. Similarly, if I divide 80 by 12, I know I have a 72, that is 6. So 8, and so the last part also will be I mean, let's do that. Um, 8's a 96, 7's a 84. And yes. So when I'm dividing 70, 80, and 90 respectively by the same number 12, the greatest number, I'm indeed getting the remainders as 10, 8, and 6. So that basically verifies the question. Seems like a good one. Now I'll just be seeing if there is anything. Nope. Chaliye. I should ideally take some more questions from the next day onward. I think from Monday onwards, I will take PYQs. Or I don't know, you guys can tell me if you're watching this on a recorded this thing. Tell me what is more preferable. CAT mocks, the past mocks, SimCAT, AimCAT, Career Launcher, or the actual PYQs. I'm telling you, if you guys ask me for PYQs, I would say कि like PYQs at this point would be a little counterintuitive क्योंकि बहुत सारे क्वेश्चन ऐसे होंगे जो possibly um, not going to make sense because they will use many topics. So PYQs का देख लो जो अगर recording देखने के बाद अगर जो भी सही लगे बताना अगर कर सकते हैं तो डेफिनेटली करेंगे राइट ओके आई थिंक this should be it. I think stream seems decent.